Aristotle taught us a long time ago that when we begin a new science, in this case we're beginning a new science of matter, we begin by classifying things. That is, if you don't yet have understanding, you begin by classifying things to see what their similarities are and what their differences are. And then as you gain understanding, you try to explain why those differences occur. This is a piece of apparatus that we use to classify matter according to its electrical properties, whether it conducts electricity or does not conduct electricity. Basically, the apparatus consists of an electrical circuit. There are wires here. This is the moral equivalent of a battery. This is a light bulb that's in the circuit. And if the circuit is completed, then the light bulb goes on. And you see it, but there's a gap in the circuit, the gap between these two electrodes. And as long as that gap is open, nothing connecting them, the circuit is open, and the light bulb can't go on because the electrical circuit's not complete. So that's how we test materials to see whether they conduct electricity or do not. We lay them across the electrodes and see whether the light goes on when the circuit is completed. Now here's a piece of steel, and we can use that as our first sample to see whether steel is an electrical conductor or a non-conductor. So we lay it here across the electrodes, and the light comes on, and so we classify steel as a conductor of electricity. On the other hand, here's a piece of what appears to be a vinyl-like substance, and if we lay this substance across to test it, the light doesn't come on, and so we classify this substance as a non-conductor of electricity. Now, here are some other very common substances that we can test with our apparatus. In one of these I have common table salt, in the other sugar. Both of them granulated. They appear, if you look at them, to be identical. So let's pour a little bit of the sugar over here, a little pile of it. And on the other side here we'll pour just a little bit of salt. And you'll see that they appear, at least to the naked eye, to be almost identical. Now we can take these substances, and with our apparatus we can test them to see whether they conduct electricity. So let's try the salt on this side, and we'll just go, ha! Well, nothing happening there, so I guess salt is a non-conductor, at least in that form. Then we could take the sugar, on the other hand, the sugar, test it in the same way. Ha! Well, sugar, at least in that form, is a non-conductor, What about water? Water's a familiar substance. Pure water now, pure water. I've put some water into these two beakers. Is water a conductor or a non-conductor of electricity? Well, we can test it. We'll just take our apparatus and stick it in there. And pure water is a non-conductor of electricity. Now I've got to warn you at this point that the water that comes out of the wall in your shower, not necessarily pure water. And this is not an invitation to take your radio with you into the shower. Now let's see what happens if we do the following thing. This is most peculiar. Consider this sugar. Well, we just showed that the sugar is a non-conductor, and the water is a non-conductor. Now look what happens. Look what happens. This is a really fascinating thing. You take the sugar, which is a non-conductor, you put it into the water, which is a non-conductor, and then you stir it. You kind of dissolve it a little bit. This is a cheap outfit we've got here, so we'll just use the finger instead of the expensive stirring rod. And there we go. Get that kind of dissolved in there. Now watch this. You took the sugar, which is a non-conductor, you put it in the water, which is a non-conductor, and now watch. Ha! Nothing happens. Never does. Nothing happens. It's a non-conductor. Well, now let's take the salt. Let's take the salt. Now, the salt was a non-conductor. The salt's a non-conductor. We'll put it in the water, which is a non-conductor, and then stir liberally, or whatever. Get that kind of dissolved like that. And now, we try this. Ha! It's a conductor. So, we classify the salt, which, when dissolved in water or melted, begins to conduct electricity. We classify the salt as an ionic substance. It's an ionic substance. Ionic conductor, if you will. But sugar, which looks exactly like it on the surface, the sugar, when dissolved or melted, is a non-conductor of electricity. It's a non-ionic substance. And so the question is, why do these two things, which look exactly the same on the surface, why are they so different? Somehow underneath, down at the atomic level, these two substances must be fundamentally different.